Hi, how are you guys? So, welcome to Data Structure Series. This is the episode 1, and we are going to talk about our first data structure called arrays. Arrays are one of the most intuitive and the foundational data structure. And also, guys, if you haven't seen the episode 0, I'm going to put the link right up here. So, if you first watch that and it's going to give you the context of this video. So, without wasting any time, let's get right to it. All right, so let's start from the start. So let's say if you are declaring variable a which saves number 5 in, what your computer is going to give you is going to give you space where you're going to save number 5 and reference it using a variable name, in this case which is a. But let's say instead of just one number, you want to save 5 different numbers, 5, 10, 15, 20, 25 for some reason. So instead of declaring 5 different variable names like a, b, c, d, e, what you can do is just put it all together and let's say call this a, right? So what your computer is going to do is give you space to store 5 different integers like 5, 10, 15, 20, and 25, and you call this a. So instead of 5 variable names, you just have to use one, and the variable name is going to point at the first element. In Python, you call this list. In C++, this is called vector, but underneath, it's all comes down to array. So, and the main distinction of array is you can access this element using integer index, and in most languages, especially in Python and C++, it starts at 0. So this is index 0, 1, 2, 3, and 4. And I have made a video that I'm gonna put a link on the top that describes that why index starts at 0 instead of 1. It's a something called pointer arithmetic, that because this a points to the first element. Let's say for example the address of this memory location is 100. So if you start it from 0, you can just add the index to whatever element you are, and it gives you the memory location of this point. Let's say if you are concerned about this location here, and you know the index of this is 3, so if you just add 3 to the first address which your variable name points to, it gives you address of 103, and you know you can directly go because this is going to be address 103. Since this is 100, this is 101, this is 102, and this is address 103. So by starting it at 0, this makes this pointer arithmetic really easy. So that's the main thing you need to remember about arrays, because in C++, C++ is more low level language than Python. So in C++ you have to say you are just gonna save integer. So whenever you declare your array, you have to say like I'm declaring vector of integer named a, and save whatever you want. So this is all have to be integers now. But in Python you can save anything. You declare list a and you can save anything inside. You can save big objects, integers, strings, anything. And every time that you use this list, the program has to go inside and manually check the data type of this. So that's why Python is a bit slower than C++, but it's more flexible. So arrays are good at something because it has this indexes 0, 1, 2, and you know the address. Let's say this is a, you know the address of this first one. You basically know the address of this location, right? Because you add address of a plus index. In this case it's 2, so you know the, let's say if it is 100, you know the location of this is 102, and you can directly access this in constant time. So that's the big advantage of using array versus any other data structure. But let's say this is your array and you are storing sorted numbers, and now you want to add a new number to this. So if you want to add number 13 to it, if you just want to add at the end, then you can easily add it because you know the location of it. But if you want to keep this sorted, what you have to do is 5, 10, and you have to add it in the middle and push this 15 and 20 to the right. So this is a little bit of time complex. So to overcome this, if you know that your program is gonna deal with this situation frequently, then maybe you have to use some other kind of data structure. In, for example, linked list is very good when dealing with this situation. Let's say if you want to find something, your task is to find whether 12 exist or not in this array. So you have to go to each array one by one and see whether it exists or not. Just because this is sorted, you know, whether if you hit 13, you know, okay, it's not going to be in the right of 13, so you can stop. But if it is unsorted array like 7, 2, 4, 15, 1, and you are looking for 3, you have to go through whole array and see whether it 3 exists or not. So in this case, maybe binary search tree would be a good data structure for you to use. And whenever we learn this all data structure, just know that some data structures are gonna perform some operations quickly and others are gonna perform different operations quickly. So if arrays are really good at accessing stuff in constant time, but not so good for searching or inserting in sorted. So we are going to learn about linked list and trees and see what they are good for. So thank you so much for watching this, guys, and I wanted to cover it in 5 minutes, but it's little more than 5 minutes. But in the next videos we are going to talk about linked list and see what are the trade-offs between linked list and arrays. So stay tuned. And if this video brings any value to you, please consider subscribing. Thank you so much and stay safe.